All right, good morning, everybody. Welcome to the very first video for AP Chem, and this is Unit 1.1. So let's get started. So I always like to start my PowerPoint presentations with a little factoid. This is not suggestive that you should fall asleep, but I figure some of us fall on either side of the spectrum. Some of us are the type that your head hits the pillow and you're out, and others of us, it takes us 30 minutes to fall asleep. Anyway, so Unit 1 is all about atomic structure and properties, and the first subunit, 1.1, is all about the mole and molar mass. So what is the mole? Well, I always relate it when I'm teaching the mole for the very first time to people that have never heard it before. I say, well, if a dozen is 12, the mole is a certain number. Okay, so there are certain words in our everyday life that mean certain numbers. Like if you go to Costco, you'll see on the sides of the boxes, you'll see the word gross. And it doesn't mean like, ew, gross. It means there's 144 of whatever that item is in that box. Okay, a ream of paper has 500 sheets. So how many things are in a mole? 6.02 times 10 to the 23rd. Okay, that's the number of things in a mole. Okay, and we're going to relate this to the term molar mass. Okay. And this handsome gentleman in front of you, that is Amedeo Avogadro, okay? And that number, 6.02 times 10 to the 23, is sometimes referred to as Avogadro's number. He didn't discover it, but they named it after him. Okay, so we're going to talk a lot about molar mass in chem. We're going to use those numbers almost every single day. So what is molar mass? Okay, well, if we have let's use sulfur as the example in front of us. If I have one single atom of sulfur, okay, it will have a mass of 32 AMUs. That stands for atomic mass units, okay? Where did the number 32 come from? You can look on your periodic table and look at sulfur's atomic mass. So one atom of sulfur has a mass of 32 AMUs. But we are not dealing with problems in just individual numbers of atoms. We're dealing with substances that are in much greater quantity. So if I have one atom of sulfur, it's 32 AMUs. If I have a mole of sulfur atoms, 6.02 times 10 to the 23rd, it will have a mass of 32 grams. Okay, that's molar mass. The mass in grams of one mole of that substance. And in this picture in front of you, you have two different substances. Sulfur is on the left, potassium dichromate is on the right. This picture is showing you 1 mole of both of these. But you'll notice the number and quantity, they look very different, okay? And that's because each individual particle weighs differently, okay? One sulfur atom has a very different mass than one formula unit of potassium dichromate. So you can see there that potassium dichromate has a much higher molar mass. Its particles simply weigh more. Okay, so it's like if I had a mole of feathers, 6.02 times 10 to the 23rd feathers, that would have a certain mass. If I had 6.02 times 10 to the 23rd dump trucks, that would have a much, much greater mass. I want you to notice the units. grams per mole. Okay, those are the units for molar mass. So the numbers that we pull off the periodic table, we're going to, instead of talking about atomic mass or formula mass, we're going to talk about molar mass from now on, and I want you to use those units, grams per mole. Okay, now for those of you that have been in my class before, this diagram is going to look familiar to you. We're going to make conversions between different quantities. Okay, and this is my little graphic organizer that I use to help me remember what goes where, okay, and what conversion factors to use. All right, so let's say we wanted to convert the mass of something into moles, or vice versa. We have a number of moles and we want to know how many grams that is. Okay. Or maybe we want to convert from number of particles, atoms, molecules, ions. Formula units, that's just a fancy term that means number of ionic compounds. If we wanted to convert between that and a mole, we can. If we want to convert between volume and moles, or any of these other quantities, we can do that. The point of this graphic organizer is to say that when you're converting, you must convert to moles first before you do anything else. So what are the conversion factors we use? To get back and forth between grams and moles, and it doesn't matter which direction we're going, grams to moles or moles to grams, we use the molar mass off the periodic table. If we're going between number of particles and moles, we're going to use Avogadro's number. If we're going to talk about volume, we're going to use this conversion factor of 22.4 liters. However, that is only for gases at STP. We're not going to talk about that today. We'll get to volume later on. So let's look at some practice problems. Okay, so I'm going to do this first one with you, right? I've got two more that I want you to stop the video and try on your own. Okay, but this is just review, okay, from Chem 1. So it says, how many grams of lithium are in 3.5 moles of lithium? So the first thing I'm going to do, and this is refreshing your memory on dimensional analysis. Okay. So I set up what I call a T-chart. Okay, remember, I'm starting out in moles of lithium. So I'm going to put that same unit, moles of lithium, on the bottom so it cancels out. And according to that graphic organizer, if I'm starting in the middle circle, if I'm in moles, my given number is in moles, I can convert directly to grams. And let's refresh our memory on what numbers go where. 1 always goes with the number mole for now. Okay, and according to that graphic organizer, what goes with grams? What was the conversion factor? The molar mass off the periodic table. Okay, so moles of lithium are going to cancel out. We multiply across, divide by any number on the bottom, and I'm going to round that to 3 significant figures. And there's my final answer. So there are 2 more problems here. Okay, I want you to pause the video, try these 2 on your own, and then come back and you can check your answer. Okay, so you can see my answers here for numbers 2 and 3. And unlike number 1, number 2 has the molar mass in the denominator now. How did I know to put it there? Because I started out in grams of carbon dioxide, so I need grams of carbon dioxide to be in the denominator, and that's where the molar mass goes. Now, number 3 was a little bit more of a challenge because it wasn't a one-step problem, it was a two-step problem. I knew that it was going to be a two-step problem though, because if I used that graphic organizer, I could see that going from grams to formula units, you have to convert to moles first, and that's what I've done here in this first step here. And then, and only then, can I convert to formula units. So it's a two-step problem. Okay, but I wasn't good about canceling out my units here, but at the end of the day, the only unit that is left is formula units of sodium chloride. So that is where we will stop. That is the end of unit 1.1, and I hope you've learned a little something. See you next time.